it's simple. It has nothing to do with, okay, it is simple, okay, that it is, we talked about it in O level, but yeah, let's talk about it again. So this is the same graph, like we agreed about. All these proteins, all these enzymes, they are proteins in nature, and proteins are affected by temperature, and temperature is the measure of how hot or how cold. But there is no measurement. You cannot quantify heat. You can quantify it in joules, but you cannot measure heat. Okay? You cannot measure heat. So the easiest way is we quantify heat into temperature. And temperature is the measure of how hot and how cold a substance is. Now, at low temperatures, the rate of reaction is low. Very low, actually. Okay? But with further increase, with increase in temperature, you can see from 0 to around 20 degrees Celsius. You can see there is a rapid, some graphs, actually a beta graph it should be, gradual, and then rapid, and then decreases rapidly. That's a good graph. Okay? Yes. So it should be, it's gradual and then increases rapidly up to a certain point. Now at that point, the rate is so high. It is the maximum. It attains actually a maximum point, a maximum rate. So what is happening at that point, and why at that point? And you can see that beyond that point, which is the optimum temperature is this, and this is the optimum rate of reaction. Beyond that point, then the rate of reaction gradually or rapidly decreases. You can see there is a rapid decrease. Rapid decrease. If you want, you can even say it's a very rapid decrease. That one is accepted. It's a rapid decrease. So why? Think about it. Why? Why a rapid decrease? So now, and why the rate is low at low temperatures and why the rate is high at high temperatures? So now, at low temperatures, the rate is low because the enzymes are inactive. All enzymes are inactivated at low temperatures. That's why when I put you in a refrigerator right now, and I reduce gradually from 40 to 37 to 30 to 20 to 18, now you start feeling cold, you start shivering. Then from 18 to 10, from 10 to 5, oh my god, from 5 to 0, from 0 to -5, you die. Why do you die? Because the temperature of the surrounding is so down, too low, that your enzymes will be inactivated. And so if the enzymes are inactivated, the rate is going to be low. So at first it decreases, but it reaches levels where there is breakdown. All physiological processes break down, and if they break down, boom, you die. But as temperature increases, you can see from 0 to around 20, from 0 to around 20, there is a gradual increase. Let me concentrate on this curve. There is a gradual increase in the rate of reaction. Why? And then there is a rapid from 20 to around 30, there is a rapid. Why? Now the gradual increase is that the enzymes are activated, are beginning to be activated, and also the kinetic energies between the enzyme molecules and the substrate molecules also increases. If you boil water, it starts when it's just cool, but by the time water boils, oh my god, the bubbling. So when you increase temperature, when you increase heat or temperature of the surrounding, then the enzyme molecules together with the substrate molecules, they absorb that heat, and when they absorb that heat, then their kinetic energies increase. And when the kinetic energy increase, then the chance of collision between the substrate molecules together with the enzyme molecules increase. The chance increases. So that at any time t, the number of collisions is always high. The number of enzyme substrate molecules that will be formed will always be high, and hence the number of products formed per minute is always going to be high. Okay? And so the rate increases with temperature. Now for every 10 for every increase in temperature by 10 degrees Celsius, the rate of reaction doubles. That's why you are seeing a gradual increase here, but a rapid increase here. It's very rapid. It's because from 0 to 10, maybe the rate is going to be at around 4 milligrams per minute. But from 10 to 20, now the rate doubles to 8 milligrams per minute. From 20 to 30, the rate doubles to 16. But from 30 to 40, the rate doubles to 32. So the increase here. So because the rate is doubling for every increase, then you will expect a rapid increase. And you will have a maximum rate of reaction at optimum temperature. Why? Because at optimum temperature here, all enzymes are fully activated with the highest kinetic energies possible between the enzyme molecules and the substrate molecules, and hence the rate at which enzyme molecules are colliding with the substrate molecules is going to be high at optimum temperature, so that you have the highest rate of enzyme controlled reaction. But beyond optimum, my dear, now these enzymes, they begin to be denatured. They begin to lose their 3D shapes. The other bonds that we saw, the ionic bonds, the sulfur bridges, the hydrophobic interactions, and the other bonds that we saw, the hydrogen bonds, they are broken at high temperatures. Why? Because at high temperatures, remember these are proteins, they are solids. You know, atoms in a solids, they have no kinetic energies. The kinetic energy that I was talking about here, it is between the enzymes and substrate, the enzyme as a whole. But here, as you increase temperature beyond the optimum, then the atoms that make these enzymes, they also absorb the heat, and they begin to vibrate within their main positions. Now, as they are vibrating within their main positions, then the forces of attraction that are formed between these atoms, the interactions between these atoms, they weaken, that they end up getting broken at high temperatures. And when these forces of attraction break, then the enzyme loses its 3D shape. It loses its active site. And when the enzyme loses its active site, then the enzyme is rendered useless. That now it can no longer carry out any catalysis. That the number of products that are going to be formed per minute is going to rapidly decrease up to a certain temperature where you are forming totally no product. And guys, it's as simple as that. So any queries, guys? Any queries?